Hello and welcome. Welcome to the third installment of this series of Adventures in Spectroscopy. The first video established the spectrum measurement setup, and the second was on emissions. See the links in the description below. In this third video, we are talking about transmission. Let's first describe the concept of transmission. A broadband light on the right is used, sends all its light to the spectrometer on the left. That's what the spectrum looks like. It's 100% transmission throughout the wavelength range. Anything added in the middle of the light path between the light and the spectrometer will absorb some light. The rest of the light is transmitted, hence the term transmission. All right, so let's measure something. Here's the setup. The spectrometer is on the left, and then I've added this plate with felt in the front so as to reduce the internal reflections in the items that we will measure, and then the light is on this side. I have grouped the transmission items in three families: household items, photography filters, and lastly, astronomy filters. That should be interesting. Okay, let's do the first group, the household items. 4 candle holders. You can see the bump in the blue region. Light blue, a little bit more green in this one. Light green, orange, magnifier. Everything seems to go through. A little bit of the blue is absorbed. Sunglasses. These have a brown tint, and so you can see that in the spectrum. Absorbs the blue, the green, and the yellow. And the deep red is passing through. There's quite a bit of infrared going through as well, from 800 to 1000. So this is to keep in mind when you wear these glasses. 3D glasses. This is the blue side. Good separation of colors here. No red at all. Red side. Good separation of color again. Infrared goes through. A piece of acrylic, clear, very clear. No influence of colors, close to 90% transmission. A bottle of olive oil. There's some magnification effect because of the curvature of the glass. Otherwise, relatively flat across the spectrum with a peak in the infrared. Bottle of wine, good wine at that. You can clearly see the green in the spectrum, so the green goes through. All other colors are mostly absorbed. This is a glass top side table. And surprise, a minion absorbs all light. Now let's do the second group, the photography filters, which will be followed by the third group, the astronomy filters. Here is an R72 filter, commonly used for infrared photography. R72 is classified for 720 nanometer filtering, and everything above goes through. This one is an IR 850. Good cutoff at 850. And anything above that seems to go through above 60% transmission. Here's one that's called IR 950 for 950 nanometers. Again, good cutoff at 950. The slope is not as steep as the others, but above that, about 30% transmission, and we're reaching the limit of the spectrometer. This one is a UV filter. It cuts off light probably below the 350 nanometer lower limit of this spectrometer. This one is a neutral density filter, 8 times. So about 12% of the light should go through. It's about right, almost flat. A little bit of a bump in the 700 nanometer. So it might have a little bit of a red tint. Here's a small infrared filter I had for my Coolpix camera a while ago. Here's a number 58 green Ratten gelatin filter. Good bandpass in the green. Cut off from most other colors except maybe for the deep red. Here is a neutral color filter from Nikon, and it's used to protect your lens without affecting the colors. Let's see if it does. Very neutral, cutting the near ultraviolet and a little bit towards a deep red. Otherwise, pretty flat and very close to 100% transmission. Okay, now that we've done the first family, household filters, and the second family, photography filters, let's do the third family, which is astronomy filters. Orion 38A blue, peaks in the 440 nanometers. Orion light green number 56. Orion light yellow number 8. Orion light red number 23A. Lumicon number 29 deep red. Andover for 30.7 nanometers, 2 nanometer bandwidth, also called G-band. That's my best filter to see the sunspots. Edmund 514.5 nanometers, bandwidth 1 nanometer. Bad Air Continuum 540 nanometers, 10 nanometers bandwidth. Bad Air U filter for Venus, 350 nanometers, and the bandwidth is 60 nanometers. Astronomique ProPlanet 742 IR filter. Astronomiques IR block filter. Bad Air Contrast Booster. Orion Ultra Block. Passes both H-beta and oxygen 3. Orion Sky Glow. Astronomique H-alpha CCD filter. Lumicon oxygen 3 filter, old version. Orion oxygen 3. Unknown Lumicon filter. This is probably H-beta. H-beta is at 486 nanometers. Bad Air narrowband filter wheel. H-alpha, H-beta, oxygen 3, sulfur 2, transmittance or luminance. There is a filter in there. Another Bad Air filter wheel. Wideband red, wideband green, wideband blue. This looks like an H-alpha, and the last spot is an empty one. This is the Bad Air Planetarium Astrosolar Safety Film, neutral density 3.8. We can see that not all wavelengths are reduced by the same factor. This is not a visual filter, this is a photographic filter. So it doesn't filter much below 400 and above, let's say, 750. A Teleview Everbright dielectric diagonal. Turn the light 90 degrees. This one is a Coronado diagonal to use with H-alpha filters for solar observing, very narrow band. This one is calcium K filter from Lunt for solar observing. So that's it for transmission. Thank you for watching. I hope that you found this video useful, and subscribe to my channel so that you do not miss the fourth and last installment of this series, which is called Reflections. Thank you.